Hello everyone and welcome to another Math tutorial video. Now I'll be discussing Form 5 Additional Mathematics, Chapter 6 Trigonometric Functions, Long Question Example 2. Okay, before that, please like this video to show your support and subscribe to the channel for more upcoming mathematics tutorial videos in the future. Okay, let me read the question now. Sketch the graph of y equals to modulus 2 cos x plus 1 for 0 less than equals to x less than equals to 2 pi. So this is the range. Continue to read the question. Hence determine the range of values of k such that the equation modulus 2 cos x plus 1 equals to k has exactly 4 solutions in the domain 0 less than equals to x less than equals to 2 pi. So this is the overall question. So I hope that you will attempt this question in the future. If you could manage to solve this question, a big thumbs up to you guys. But if you can't solve this question, no worries. I'm going to show you the step-by-step working and the solutions. So without further delay, let us start to solve the question. Let us begin our discussion. Okay, for the first step, what we need to do is we need to sketch the graph of y equals to modulus 2 cos x plus 1 for the range 0 less than equals to x less than equals to 2 pi. Okay, if you take a look at the right side of this working, I've actually completed the sketch of first two graph. The first one, if you can take a look, is y equals to 2 cos x, and the second one is y equals to 2 cos x plus 1. Okay, now you can ask me, so why you literally showed these two? Okay, the reason is so that you can able to understand the process of getting to this graph, guys, where you need to form y equals to modulus 2 cos x plus 1. Okay, so at the end you only need to show this final graph. Okay, you don't need to show these two steps. Okay, so from here let me explain this first sketch. Okay, y equals to 2 cos x. Okay, it mentioned here 2 here. Okay, this 2, it's indicating the amplitude. Okay, so your highest value will be indicating 2 over here and negative 2 respectively. Okay, and this is how you form your graph of 2 cos x. Since you don't have the coefficient of x over here, it's just the 1. Okay, so you complete one oscillation within 0 to 2 pi. Okay, you've completed one cycle, guys. Okay, in this case from 0 to 2 pi. Okay, so this is the graph of y equals to 2 cos x. Okay, moving on to the graph y equals to 2 cos x plus 1. Okay, the shape of the graph still look the same, but the only thing difference to this graph, okay, there is a plus 1 over here. Okay, this plus 1 has a difference, guys. Okay, literally this plus 1 meaning that, okay, you are actually moving the position of y by 1. Okay, that means you're moving the position of y by 1. Okay, let's say in the previous graph you have negative 2. Okay, when you add plus 1 over here, your least value will be starting from negative 1. Okay, and your highest value will be changed to 3. Okay, this top value and bottom value will be changed by positive 1 respectively, guys. Okay, so that is the difference between y equals to 2 cos x and y equals to 2 cos x plus 1. Okay, other than that, the oscillation still remains the same, one oscillation within 0 to 2 pi. Okay, so that is the graph of y equals to 2 cos x plus 1. Okay. This is the graph that you're going to sketch now, that I'm going to show you right now, where the y equals to modulus 2 cos x plus 1. Okay, as you take a look over here, it is related to this second graph, but the only difference is now we having a modulus symbol over here. Okay, this is meaning that, okay, under here you have the negative region. Okay, this negative region will be automatically reflected at the positive region over here. Okay, so that will be your graph of y equals to modulus 2 cos x plus 1. Okay, enough with the talking, let us start to sketch the graph now. Okay, so please wait, guys. So this is how your graph should look like when y equals to modulus 2 cos x plus 1. Okay, so from here we have already done with the step number 1. is to sketch the graph of y equals to modulus 2 cos x plus 1. Okay, for the next step, what we're going to do is we're going to determine the range of values of k such that the equation modulus 2 cos x plus 1 equals to k has exactly 4 solutions in the domain 0 less than equals to x less than equals to 2 pi. Okay, so from here what we're going to do is we're going to write down the equation given by the question in our working. So from here, modulus 2 cos x plus 1 equals to k. So since in our sketch we mentioned that y equals to modulus 2 cos x plus 1, we can also let this modulus 2 cos x plus 1 is equals to y. Okay, so I hope you guys are clear. So from here what you're going to do, we're going to substitute modulus 2 cos x plus 1 equals to y. So from here you should get y equals to k. So this is the equation that we need to find, the range guys that we need to find. Okay, so from here y equals to k is indicating that it is a horizontal straight line. Okay, your k is a constant. Your constant value can be any value. It could be 2, or it could be 3, or it could be 1. It could be any values. Okay, so from here what we need to do is we need to find the range of k such that it fulfills the 4 solutions. Okay, what it means that 4 solutions? Okay, the intersection between the horizontal straight line and this trigonometric curve, it should be 4. Okay, you must have 4 intersections. If you don't have 4 intersection, it is not fulfilling the range required by the question. Okay, so for this step what we're going to do is we're going to use the trial and error method guys. Okay, there is no specific calculation for this step. So from here what we're going to do is we're going to start with the y equals to 3 itself. Okay, so from here when your straight line y equals to 3, okay, let's say this is your y equals to 3 straight line. So from here, as you can observe here, you only have 2 intersection, one at the starting point and one towards the end. Okay, you have 2 intersection. Okay, these 2 intersection does not fulfilling our conditions. Okay, since in the question we are required to find 4 intersection. So from here y equals to 3, okay, is not our range, in our range. Okay, so from here let us try the next straight line, okay, which is 1. Okay, so from here y equals to 1 is already here in the dotted line version. Okay, however if you observe carefully, you only have 3 intersection. Okay, 1 is over here, okay, and then 2 it's exactly at the middle point. Okay, and then this is the 3rd intersection. Okay, this is also still not sufficient as we need 4 intersection point. Okay, so from here where is the position, where is the region that we can fulfill the 4 intersection? Okay, if you look closely, is between 0 and 1 guys. Okay, this is the region that we can obtain 4 solutions. Okay, if you still not convinced, okay, let me show you one simple example. Okay, let's say you take your y equals to 1 over 2 for example. Okay, and you draw a straight line over here. So from here let me mark the intersection. So from here you have 1, you have 2, you have 3, okay, and you have 4. So now as you can see, it is fulfilling the 4 solutions. Okay, you can have the 4 solutions provided that it must be in the range of 0 and 1. Okay, your k value must be more than 0 and at the same time it must be less than 1. Okay, so I hope you guys are clear about this. So this is the answer guys. Okay, so from here, to obtain 4 solutions, so from here your k should be more than 0 and should be less than 1. So this is your final answer, guys. Okay, we have already sketched the graph and mentioned the range of k. So let me underline the solution. Okay, so that is all for the step-by-step working and solution for this question. I hope you understand the full working that I've shown to you. If you like this video, please give your thumbs up. If you haven't subscribed to the channel, please subscribe to the channel and hit the bell icon for more upcoming mathematics tutorial videos in the future, and not forget to share this video. Thank you everyone for your support, and I'll see you in the next video.